The transpiration pull is so powerful that it can raise water up 100 or more meters in trees. We have evidence to support this theory, including the following. The diameter of tree trunks is going to change according to the rate of transpiration. During the day, we have the greatest amount of transpiration because the sun is out and we have a lot of evaporation of water. So we have a lot of pull on the transpiration stream. So we have more tension in the xylem. So this pulls the wall of the xylem inwards, and the trunk is going to actually shrink in diameter during the day. At night, transpiration is at its lowest because we don't have a lot of evaporation since the sun is not out. We have less tension in the xylem, and the diameter of the trunk actually increases in the plant. This supports the cohesion tension theory. A second piece of evidence is that if a xylem vessel is broken and you allow air to enter in it, the tree can no longer draw up water, because now you broke the continuous column of water. We have air spaces in between, so the water molecules can no longer stick together. Third, when a xylem vessel is broken, water will not leak out, because you don't have pressure. Water cannot leak out unless you have a pressure gradient. Instead, water is drawn in, which is evidence that we have negative pressure within the xylem. This is consistent with the xylem being under tension. So this is the evidence that supports that we have the cohesion tension theory, that it stands. And this transpiration pull is actually a passive process, so we don't need metabolic energy for it to happen. And actually the xylem vessels are made of dead cells, so we don't have any active transport of water or active movement of water. The xylem vessels have no end walls, so it's just a series of continuous hollow tubes from the root to the leaves, and this helps with cohesion and tension. The place where energy is needed is to evaporate the water at the surface, and this comes from the sun.